Morning friends, study with the Pala Engineering and General Geology Parvin Singh book. Zonal distribution of subsurface water. The water that goes below the surface of the land may be found to exist in two main zones or environment classified earlier as Wedo's water and phreatic waters or groundwater. In the Wedo's water zones itself, three different types of environments are distinguished: soil water, intermediate Wedo's waters, and capillary water. So this is most important picture. So groundwater and Wedo's water. So runoff ये दिखा है water. PS means a zone of a permanent. NCF means a capillary fringe. वाटर टेबल दिया हुआ है. ZA means a zone of variations और SZ है zone of soil water. This here. The soil waters forms a thin layers confined to the near surface depth of the land. It may occur at depth between 1.0 to 9 meters and is held up by root zones of vegetables cover and soils, chemicals. This water is very important for the life and growth of the vegetables covers of the globes. It is lost to the atmospheres by transpiration and evaporation. The intermediate Wedo's zones occurs immediately below the zones of soil water. It is in fact a zones of non-saturation. Water in this zones is moving downwards under the influence of gravity. It is generally of small thickness and may be even absent in many cases. The above two zones are sometimes collectively referred as zone of aeration. The zone of capillary waters, water capillary fringe, is present only in soils and rocks of fine particles size underlines the Wedo's zone. It is absent in the coarse sediment in the fine particle size. Zones groundwater is drawn upwards by capillary action, sometimes to height of 2 to 3 meters above the saturated zones lying underneath. Growth of vegetation observed in some desert is very often dependent on the presence of the capillary fringe. The cause of rise of waters rather than its downwards movement in the capillaries of fine sediment is the well-known force of surface tension. The phreatic water zones, also called the zone of saturation, lies below the capillary fringe, and it is the water held in this zone that is called groundwater in the real sense. The upper surface of water in the zones mark the water tables in the areas. In these zones, the layers or bodies of rocks which are porous and permeable have all their open spaces such as pores, cavities, and cracks. It's completely filled with groundwater. All these openings are thoroughly interconnected so that a well dug into this zone receives water from the entire saturated rocks mass called the aquifer. Since in these zones all those openings are completely filled with water, there is no or very little downwards movement of groundwater. The predominant movement is a types of lateral flow controlled by the head of the waters or levels at different places, following from the higher head to lower head in order to achieve a level surface everywhere. In all the groundwater exploration programs, the main objectives is to locate this zone and determines its extent, geometries, and character. In many cases, a significant rise and falls in the levels of zones of saturation is observed as a characteristic features during different parts of the year, depending upon rainfalls and recharge. A third zone of intermittent saturation is thence easily recognized, which mark the depth and between the zone of Wedo's water and aerations and the zones of permanent saturation. This zone of intermittent saturations will yield water only during and immediately after rainy season, becoming a non-yielding zones for rest of the year. Water bearing qualities of rocks. All rocks are neither capable nor suitable for holding and transmitting groundwater. The following terms should be understood clearly before discussing the water-bearing qualities of rock. Aquifer. It is defined as the rock mass, layers, and formation which is saturated with groundwater and which, by virtue of its properties, is capable of yielding the contained water at economic cost when tapped. The quality of an aquifer will therefore depends both on how much quantity of water a rock formation can hold per unit volumes and at what rate it can yield water when tapped for supplies. It is a storage reservoir and transmissions conduct at the same time. Gravels, limestone, and sandstones generally forms a good aquifers when occurring in suitable geological condition and geographical situation. Aquiclude. A rock body of formations which may be porous enough to hold enough quantities of water but which may, by virtue of its other properties, do not allow an easy and quick flow through it. It is called an aquiclude. It is to be treated as a practically impermeable rock mass. Compacted clays formations are the best examples of aquiclude. Aquifuse. It is an absolutely impermeable rocks formations through which there is no possibility of storage or movement of water. Such formations is almost free from the pores and others interstices. Examples: compact interlockings, granites, and quartzite. Aquitard. It is a less common term used sometimes for an aquifer fuse or aquiclude that has become locally leaky and due to development of a partial previousness caused because of profuse jointings or cracks. Type of aquifer. Two basic types of aquifers are distinguished on the basis of physical conditions under which waters can exist in them: the unconfined aquifers and the confined aquifers. Unconfined aquifer, most important topic. Please be concentrate and learn this. It is also called the water tables aquifers and is the most common type encountered in the field. In this types, the upper surface of water or the water table is under atmospheric pressures which may be acting through the interstices in the overlying rocks. In figure नीचे है ये. The water occurring in these types of aquifer is called free groundwaters. When tapped through a test wells, the free waters will rise to a levels in the wells equivalent to the water tables of the area. Water tables, the depth to upper surface of zones of saturation in free groundwater is called water table. It fluctuates depending on many factors and may be as low as 1 meters or so or as deep as 100 meters or more. Perched water tables is the terms used for isolated water table in an aquifer held by small extensions of impervious rocks within a large previous tract. In such cases, the man's water table is located much below the supplies from such isolated reservoirs. With the perched water tables are often unreliable. तो ये अनकन्फाइंड एक्विफर्स वेल है और वाटर लेवल्स वाटर टेबल. In this diagram, MWT means water tables and IMP impervious zones. This MOP 1020. PWT, MWT. Confined aquifer. It is a rocks formation saturated with waters and capable of yielding water tapped, but unlike unconfined aquifers has an overlying confining layers and impermeable rock mass that separate it from the influence of atmospheric pressures. Naturally, water held in these types of aquifers is not under atmospheric pressure but under a great pressures due to the confining medium. The upper surface of water is in a confined aquifers. The confined water is called piezometric surface. For establishing a piezometric surface levels of water in a number of test wells has to be made. As artesian aquifers is in fact confined aquifers of such a geometry developed in suitable geological situations, so that piezometric surface is always above the ground levels at many places when projected in elevation. When water is tapped from such confined aquifers, it rushes up to even above the surface and may rise to the heights theoretically equivalent to the projected piezometric surface, and such well are called artesian wells and fluent wells, and the type of groundwater obtained from them, which often need to pumping and artesian water. So this is the diagram. Please make a diagram. Artesian aquifer, and AQ indicate aquiclude, or AF indicates aquifer, and PS indicate piezometric surface. Please, thank you. Give a positive response. Thank you.